Deep in your app there's a space filled up by a great database. Its tables are where information goes, made of cells inside columns and rows. To speak to it, we can connect using insert, update, and select. With a language that has no equal, we need more people to try SQL. SQL!
Welcome to the third level of the Tri-SQL course. Let's continue with some more exciting topics in the database language called SQL. Here in section 1, we'll be creating and removing databases and tables. So far, we have learned quite a bit about how to retrieve and manipulate data using SQL. Now let's take a look at how to create databases and tables, as well as alter the actual table structure within a database. So how can we use SQL to create a completely new database? We will add a new theater to the list of databases. Our next task will be adding a new theater to the list of databases. But how can we do that using SQL? Let's take a look. First, let's review the structure of the first database, Gatsby Theaters. The original Gatsby Theaters contained 4 tables. We wish to create a database similar to this. We will call the new database the Chaplin Theaters. It will be empty at first, containing no data. Taking a cue from the Gatsby Theaters, we know that we'll need 4 tables. Let's see how to get to that point. To establish a totally new database on our server, we will use a brand new secret recipe called the create database recipe. Basically, it starts with the create database key phrase, which is the SQL statement to create a database, followed by the name the database will have. We execute the create database statement and voila! We have a brand new database called the Chaplin Theaters. Since it is a new database, it is also an empty database, but we'll see how to change that very soon. Before we look at adding tables, structure, and data and all of those things to this new database, let's also see what it would take to completely remove a database. Scary, right? For example, say we realize that we don't need a new Chaplin Theaters database at all. How would we get rid of that? When we remove a database, be it old or new, it is known as dropping a database. So for that, we'll use what is called the drop database recipe. It starts with the drop database statement to remove the database, and is followed by the database we wish to remove. But be careful. When removing or dropping a database, it's important to remember that once the drop database statement is executed, the database and all of its contents will no longer be available. So, if we actually ran this SQL statement, the new Chaplin Theaters database would have been completely removed. But we're glad we didn't do that since we still have plans for it. Okay, let's assume we did not drop our database and that we still have our database set up for Chaplin Theaters. Let's see how to create a table inside of that database. We want to create a movies table inside of the Chaplin Theaters database that will hold data for other films that we wish to list. We will use the create table recipe to do this. The create table portion signals that a new table will be created on the database, followed by the name we want our table to have. A set of parentheses surrounds the table structure, while inside the parentheses we state the name we wish the columns to have, followed by a data type. Now, don't be scared of these data types. They just tell us what kind of value the column must contain. When creating a table, every column must have a data type, and we use a comma to separate each column in our list. Looking at how we wish to create the new database, based on Gatsby Theaters, we know that we have the data for movie info, concessions info, showtime info, and promotions info. You may notice none of this data has any table structure. The first table we will add to the new database will be the movies table, which will hold the movie info data. Before we actually create the table, let's take a look at how we want the columns inside to look. So, if we're looking at the raw data, this is how it will look in all of its shining glory. Not so impressive, right? In many instances, table data is taken from spreadsheets or other sources in some format or another. It is from these sources where we'll decide how to build the table columns. From the spreadsheet, we see that we have 4 columns of data. Each one of these columns has a different kind of value, which will help us determine how we will create new columns in the table. Over here, the first column has the title of ID. It appears to be made up of only numbers which continuously grow incrementally. So, when we look at the new movies table, we will name the first column ID. And since this column will hold only numbers, we will give it a data type of int, which is used primarily for numbers or integers. Since we also wish for the numbers to grow incrementally in this column as we add more data, we will use this column as the primary key. Now, a primary key can be set in a number of different ways, and we'll look at those ways in the next course. But for now, just know that ID is serving as a primary key and will automatically be incremented as data is added. Next, we have the title column from the grid of data. It looks like this column is where the film names are given, but could be letters and/or numbers depending on the actual name of the movie title. Knowing this, we will give the second column a name of title with a data type of varchar. This data type allows the data here to have a variable length of letters and numbers within this field. Let's give this data type a length of 50 digits, which means that no matter what the data is here, it cannot be longer than 50 character spaces. The third column on the spreadsheet has a name of genre, which appears to hold a description of the type of film for each movie. This value, like the previous title column, is made up of a string of letters as well. Like the title column, we will make the genre column a data type of varchar. Usually, a film's title can be longer or shorter than its description. Therefore, we'll give the genre a lower maximum variable character length of 15. The last column from our data grid, duration, looks like it only holds numbers. So, based on that fact, we can finally name the last column duration and give it a data type of int. The data type may appear to be the same as that of ID, but we know that movie times can be the same. Therefore, this column will not be the primary key or hold unique values. Once we run the SQL create table statement, we can see that we have successfully created the movies table inside the Chaplin Theaters database. There are many different data types which can have a lot of different properties. More information on these can be found on the web in a number of places, but we'll leave this up to you to research as you wish. Looking at the new table, do we actually have any data inside of it? Not yet. So it looks like it's time to add, or insert, some data into the table, which we already know how to do. But let's say for some reason that the new table wasn't created correctly. How would we remove it from the Chaplin Theaters database? Like removing a database, we would drop a table from a database to remove it. Let's take a look. Here we have the drop table recipe, where we signify that a table is to be removed with the drop table statement, followed by the name of the table we want to remove. Looking at the Chaplin Theaters database, here's what would take place if we chose to remove the movies table from the database. We would run our drop table statement, removing the table from the database entirely. It would no longer be available to use by the Chaplin Theaters database. And that's all there is for this first section of Level 3. Now it's time for some more challenges, and we'll see you back in the next section.